Hey all, Grollo here. Hope y'all's week is starting to wind down nicely. The weekend is nearly upon us, and that is worth something. So we spent a lot of time on this channel talking about game servers and sharding and scaling and all of that. And I mentioned in the last video that Relax Gaming dropped a comment in one of our videos a few days back, suggesting I take a look at the SpacetimeDB reveal. So today we're going to do just that. How differently are they doing things? I don't know. Let's dig in. So Clockwork Labs is a new venture-backed game studio. And unlike CIG, as far as I can tell, this company seems to be have planned to productize and monetize their back end, as we will see shortly. Versus CIG, who seems to have kind of stumbled into Star Engine. Not that stumbling is bad. It's just two different ways at arriving at a destination. Clockwork Labs seems to have set out to create two products, an MMO backend and an MMO. CIG also set out to create two, but it was two games. And along the way, they coined Star Engine. Oops. But hey, they're in good company. It always seemed to me that Amazon kind of stumbled into AWS, you know? Like they set out to create the platform that they needed to scale Amazon.com and then said, well, shit, we can sell this. And now they own the internet. So stumbling into something isn't necessarily a worse approach than planning your way into something. Both ways can go poorly. You know, you can plan to do something and fail to realize how your plan doesn't match the market or demand, and produce something that lacks any real value. Or, you know, you can stumble forever and never really create a product. Trade-offs, right? Anyway, so Clockwork Labs is making a game called Bitcraft Online. And as they say right here, it'll be a massively multiplayer societal game that will be less focused on pure combat and instead encourage social interaction and cooperation between players. Which basically means it won't be the game for me. I don't know. I mean, I'm sure it'll be cool, but I really love my combat. But that's okay. Not every game has to be made for me. I'm sure a ton of people will love a societal game. I mean, look at Minecraft. That game definitely was not for me, but probably did better than any game I ever played. So Bitcraft, they have a website for here at bitcraftonline.com. And this is like their first offering, like as far as I can tell, Clockwork Labs. So Bitcraft is the first large-scale survival crafting MMORPG. Work with thousands of other players to rebuild civilization in a single massively uncharted world. Blah, 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 blah. I don't know about first, maybe, I don't know. This conceptually, it sounds a lot like PAX Day to me. Let's just watch a few seconds of the trailer here. right, I think we get the idea. The combat sure doesn't look impressive. Do you see that spear jab? But it definitely seems a lot like PAX Day and Spirit to me, except PAX Day is built on UE5 and very traditional backend. It's using UE5 server and UE5 server meshing and etc. Also, PAX Day aims to have great combat, but it doesn't yet. PAX Day's combat honestly looks just as bad as this game right now. So, the combat sucks, which is why I'm not playing it. But I'm still looking forward to PAX Day, and I will definitely play when they get their act together on the combat. Okay, back to Bitcraft. Now, the really interesting thing about this game, which we already started talking about, is on the About page. Go to their About page and you scroll all the way down here. What engine does Bitcraft use? The Bitcraft client is developed using the Unity game engine. Oh boy. Good luck with that. Did Unity ever fully backtrack on all the bullshit they were trying to pile on to their users? I kind of lost track on what was going on there, but I hope it doesn't bite these fellas. And then, of course, for the server, we have developed a sophisticated distributed system called SpacetimeDB, which hosts the entirety of Bitcraft's server architecture. We feel that SpacetimeDB offers a step change reduction in the complexity of developing persistent world MMORPGs, and we hope that it will open up an entirely new genre of indie developer, massively multiplayer games. Okay, that's a mouthful. They have a webpage dedicated to SpacetimeDB here. Here it is. It's got the GitHub stars here and all that. It's written in Rust, and it's doing the open source with paid premium hosting and support model, kind of. If you go to their pricing page, they sell energy. And I'm not sure what this converts to open source in 4 years. I'm not sure what that's all about. I'll have to dig into that, but that's not important for now. Okay, we may come back to this page in a bit and dig in more, but let's keep moving. We got a lot to cover. On this site, they published an introduction or an introducing SpacetimeDB 1.0 article a few weeks back on March 4th. And they accompany this announcement with a video. So we're going to watch that right now, and I'll drop comments as I have them. So let's roll it.
I'm Tyler, founder of Clockwork Labs. We're a 40-person game studio, and we're developing an ambitious game on top of some really cool technology. I've been looking forward to this day for 5 years, because today we're going to share that technology with you. We've got a lot to get through, though, and it's only just the beginning. The game we're building is Bitcraft, an epic survival crafting, massively multiplayer game, where all players join the same world and rebuild civilization from the ground up. The entire world is editable. Players can cut down forests, or build roads, or construct massive cities and trade routes. Bitcraft is our studio's first commercial game, and conventional wisdom is that you should never build an MMORPG as your first game, much less one of this scale and complexity. And this is the reason why. MMORPGs have historically been hugely complex engineering projects, requiring specialized engineers from many disciplines. We're talking hundreds of developers, over 5 to 7 years, with budgets in the hundreds of millions of dollars. Not only does this restrict who can participate in the genre to
5 to 7 years on the low end.
exclusively large companies, but coordinating 250 people while also risking $200 million restricts how much experimentation you can do or how creative you can reasonably be. We've never had those kinds of resources. So in the words of Ernest Rutherford, we were going to have to think. We needed to approach the problem from a completely new direction. We needed to dramatically simplify the back-end architecture so our game devs could focus on gameplay and game design and not distributed systems and microservices. I'm proud to say that over the past 5 years, we've done exactly that. With only a handful of game engineers, we've built a fully featured MMORPG operating in production and at scale. Tens of thousands of players have explored the world of Bitcraft in our alpha tests already. And with millions of players signed up to play, many more will be exploring it in our upcoming beta. And today, I couldn't be more excited to share with you the revolutionary technology that got us here. SpacetimeDB 1.0.
If nothing else, it's a cool name.
Production-ready, all-in-one backend solution for your multiplayer games. So let's get into it. If we want to understand why SpacetimeDB is so revolutionary, we need to understand how MMORPGs are built today and where existing solutions stand for small teams. What makes them so much harder to build than indie games from a technical perspective? Well, large companies don't use off-the-shelf solutions. They typically build their own backends and distributed systems from scratch using cloud services. If you want to build an MMO that way, then at a minimum, you're talking Docker, Kubernetes, proxies, IAM roles, VPCs, load balancers, databases, web servers, game servers, custom networking configuration, real-time networking, microservices, two-phase commit protocols, analytics.
Hold on, let's go back there. I want to see this. I think on this channel we've talked about almost all of this at one point or another in one of the videos. Yeah, looks fairly accurate. I don't think we've talked about backups and analytics, but most of the other stuff. Yeah, okay. Let's keep going.
Microservices, two-phase commit protocols, analytics services, logging services, chat services, and on and on. You need dozens of specialists to build it, and then a whole team just to keep it running.
True.
And there goes your budget. By contrast, for a single-player indie game, it's pretty simple. I write my game in a game engine, I take my game program, I install it on my computer, and I run it. Simple. My operating system abstracts over all the hardware underneath. Network cards, GPUs, CPUs, memory, etc.
So far, we're comparing a single-player game to an MMO. I don't even know how you compare those two things, but okay, I'm sure he's going to get to a point.
Dev needs to know is the game engine and how to program. So is there a solution out there that makes it this easy to build an MMO? Well, let's take a look. I've made sort of a business 101 graph with whether something is a complete solution on one axis and how easy it is to use on the other axis. In the bottom right corner, you've got your core technologies and very specialized tools. These are great tools. They're super easy to use, and they solve their specific problem extremely well. But they're only a small fraction of what an MMO needs. Right here in the middle, you've got your game backend solutions. Since they're designed for games, they definitely solve a lot more of the problem for you, but none of them handle persistence, and they're also very opinionated. If you color outside the lines of what they were built for, they become very, very hard to use.
Everything today is going to inch closer to hard to use as it gets to a complete solution. And I guarantee SpacetimeDB is going to be in the upper right quadrant. That's what every sales pitch shows.
And that puts us back up here, where we started. Cloud services and rolling it your own. The cloud's got everything you need, but good luck with that. There's a clear trend here. The closer you get to a complete solution, the more complex the problem becomes. And if we just add to this line, well, then we've failed. In fact, in order to build Bitcraft, we had to think about something completely different. This is SpacetimeDB. Everything you need and stupidly easy to use.
Of course. There it is. The perfect. Okay. I'm not going to bust on them. I'm not saying this is impossible. I'm just, you know what I'm going to say. Everything's a trade-off. You can get things that are moving towards complete solution further to the right, but the way you do that is with massive amounts of opinions. And so the thing you're going to be building on top of this is not going to be able to make many decisions. It's going to have to do it exactly how it's prescribed by the thing you're building on top of versus the the cloud approach that they're talking about using AWS, GCP, you basically have infinite flexibility there. You're going to be able to make all the decisions that you want. If you think like Star Citizen today, like they are building the exact engine they need for that game, and they're able to do that because they're building on top of the primitives that are GCP and AWS and the other cloud primitives. So yeah, let's keep going. I'm sure they'll begin talking about the opinions here soon.
So what is everything you need? We believe that there are really just 3 foundational ingredients: storage, compute, and networking. And they all need to scale. In particular, you need transactional storage, server-side compute, and real-time networking. Let's see which of these ingredients each of the existing solutions has. You've got Firebase, which has transactional storage and real-time networking, but no server-side compute. You've got stuff like Unity Netcode, which has compute and networking, but not storage. None of them have all of them, except for SpacetimeDB. In fact, SpacetimeDB is so simple, it only has 3 features, and they correspond exactly to those 3 ingredients. Tables provide storage, reducers, which are essentially cloud functions, provide compute, and subscription queries provide real-time networking. So how does that work? Well, you write your game's backend as a SpacetimeDB module. A module is a simple program written in whatever language you like. We officially support Rust and C# modules today. Tables are database tables. SpacetimeDB is a relational database. You declare your tables right inside your code, just like you would using an ORM to connect your server to your database. Here we have a table defined in a Rust module on a player struct. The fields correspond to columns in the table. Very simple. Next, you define your reducers. Reducers are stateful, transactional, cloud functions. They're basically the same functions you'd write in a regular game server. They run computations and update tables. You can do whatever you like: authorization logic, physics calculations, anything really. It's just regular server code. Then you take that module code, compile it to WebAssembly, and
this is a growing trend, defining your data structures, tables, whatever, in your code, and letting the platform provision and manage it. This is definitely not the first time I'm seeing this, but we'll talk about that more later.
And upload it to run on SpacetimeDB. You connect your clients to the database and call reducers, just like regular functions, with our powerful SDKs and code generation, or make subscription queries against the data. Subscription queries are just regular SQL, but with a twist. With subscription queries, we evaluate your query and return the results. But we also maintain the connection and send your client updates so you can see the results change in real time. SpacetimeDB abstracts over the cloud, just like your desktop OS abstracts over your hardware. All that.
Live queries are also something that a lot of databases offer, and APIs in general, like GraphQL subscriptions. Yeah.
Left is to crank it to 11. You can connect thousands of clients with each making multiple calls per second. SpacetimeDB 1.0
Cool.
is fast enough to handle all the server-side logic and all the real-time subscriptions for thousands of clients simultaneously. That's pretty much it.
Well, I'm sure they're going to be achieving that through sharding. We've talked about that plenty on this channel. The way you scale is sharding. It's exactly what CIG is doing with their entity graph. It's what any game does. It's how Unreal 5 servers scale. It's how PAX Day is going to scale. It's how Ashes is going to scale. It's all about sharding. So I'm sure they'll talk about that soon. But in order to scale to thousands, going to have to be many of these SpacetimeDB instances all kind of collaborating. I'm sure that's what they'll be talking about.
You now know how to make an MMORPG. And that's no exaggeration. The entire backend of Bitcraft runs exclusively and entirely on SpacetimeDB, with just those 3 ingredients: chat messages, terrain data, players' positions, buildings, AI, physics, everything. So how are we able to do all of this in a database? I thought databases weren't meant for this. Well, existing databases aren't meant for this, but SpacetimeDB is. You see, ordinarily in a database, your code is separated from your data by the network. In order for your game logic to access your database data, you've got to serialize a query, send it, go all the way through the OS stack, over the network, up the OS stack, receive, parse, plan, execute, and then go all the way back. This can take 400 microseconds at best and tens of milliseconds at worst. In SpacetimeDB, all of that is simply just gone.
Yeah, I've seen this kind of charts before. I kind of know what he's getting at. We call this data gravity, and it's the notion that it's easier to move compute to the data than it is to move data to the compute. And by that, what I mean is, like, imagine you have a game server sitting here, right? And you have a mountain of data sitting over here. And if your game server needs a lot of the data sitting over there in order to run the computations and calculations that it needs to run, you wind up transferring a lot of data from your data layer, your database, whatever you're using to persist that data, to the game server on a very routine basis. Like you're transferring data all the time. Now, if you could move the game server code to the data so that that back and forth transfer isn't happening, obviously that's a huge win. You're saving a ton of network bandwidth. And as we've discussed on this channel before, like, network bandwidth is a limited resource. It's one of the things I called out as causing, proximity problems to Star Citizen, and there's all kinds of other things that can manifest from that. But this concept of data gravity and moving the compute to the data is definitely not a new concept. This is something that we've been doing for a long time. I will say that it's relatively newish in the API space, where at least where I saw it start was really in the big queries and things like Hadoop and AWS EMR, and I even worked at a company that went by the name of Joyent that was doing some of this stuff. They called it Manta. It was a storage system we were developing to compete with to compete with AWS's blob storage S3. And one of the key differences was that they allowed you to run arbitrary calculations, basically similar to MapReduce, but they were more focused on like Unix tooling, like at the data, so that you didn't have to transfer the data. You could send the instructions to the nodes that were persisting the data and actually run the calculations or the analytics or whatever it was that you were doing, like on the node that was storing the data, so you didn't have to move the data. You didn't have to transfer it over the network. And all it is to say, that seems to be what they're talking about here. I'll break this down better as we go through this video, but I just want to pause and expand on that a little bit.
Putting your code nanoseconds away from your data.
Exactly.
We store your data in memory, in cache-efficient tables, right next to your code, which is running in the same process. There's very little overhead beyond what you'd find in a typical game server. In fact, the internal representation is similar to a highly performant ECS architecture. We are talking less than 1 microsecond round trip times rather than 400. Pretty stark. And that's not all. Even for large batch queries that don't go back and forth across the network, SpacetimeDB is way faster. Consider the straightforward operation of updating the positions of 1 million entities in your game. Here's the query written in SQL and the equivalent as a SpacetimeDB reducer. Postgres takes over 3 seconds to execute this query. SQLite, running in memory, takes over a second. SpacetimeDB takes just 200 milliseconds. That's almost 5 million rows per second. Even in this best case scenario for Postgres, SpacetimeDB is over 15 times faster. With this architecture, we give you near bare metal performance while being 10 times easier to use. SpacetimeDB can easily simulate physics and collisions for thousands of entities moving around in a single world, giving...
It keeps talking about reducer. I'm going to explain that really quick because it's kind of important, and I'm sure some of you might be wondering what that is. So, you can think of a reducer as a function. I think based on what I understand about SpacetimeDB so far, this is a pretty good choice. I've actually chosen this for a similar project in the past, but if you imagine SpacetimeDB as a database, now it's not exactly a traditional database, obviously, but if you just imagine this is like where the data is stored, right? Let's just imagine we have one SpacetimeDB server right now. A reducer function will be something like update, or I'm drawing with a mouse, which I suck at, but update name might be one reducer, right? And there is a record in the database here, and your game client sitting over here. This box is your game client, and it's going to execute the update name reducer. It's going to give it a key. A key is what you call something that identifies this database record over here, right? It could be like an ID, like 1, 2, 3, 4. It could be like a string of random, seemingly random characters. It could be anything. But you'll pass the key of the record that you want to update, and you'll pass some kind of input, right? And the way a reducer works is it'll take the record from the database, which it identifies by the key that you're passing in. It takes the input from the game client. So not only are you going to pass in a key, but you're going to pass in some input, right? In this case, if we're updating the name, it's probably just going to be a string. Whoops, I don't know why I did a E on the end there, but you'll pass some input. So it takes the key, it reads the record in from the persistence layer. It runs this function, which receives the input, right? And it combines the input with the previous state, which is the record that it just read from the disk, and it generates a new record, and it writes that record back out to the disk. That's a reducer. That's like the kind of the state reducer pattern. There's a lot of things that use this pattern, and you'll have, in a game or whatever, you'll have as many reducers as you need, probably hundreds and thousands for something like Bitcraft Online. And the game client can call any one of these with an input object, a key, and it'll create a new version of the record. So that's how that works. As far as other things using this pattern, like I said, there's a lot. Redux is a popular state engine that a lot of web applications will use to manage the state of a web site or app or whatever. And it uses this exact same pattern where you have like your state object sitting in memory, and you have a bunch of reducers that are used to interact with it. Same thing. This is another word for this is a fold. If you go out to Wikipedia, look up fold higher order functions. This kind of explains the same pattern. I was working on a project a number of years ago where we were doing something that we probably had no business doing, but it was a lot of fun. This was in the early days of Kafka. There wasn't a whole lot of things that did this for you yet, but we were basically working with a bunch of microservices and larger services, and the change data capture pattern was common. Sorry if I'm talking over. I'm going to boil this down. Don't worry. But if you don't know what Kafka is, it's just like a big log file. And you'll have like a bunch of other processes kind of listening to what's going on this log. It's called a distributed log. So for example, if one application says, hey, a new user just registered for the application, it'll write a message out to the log. It'll say, new user registered for app. You might have other services that are interested in whether a user registers for the app. Maybe you have a service that sends new users welcome emails. Hey, welcome to the service, right? So it'll listen to that log. It'll say, hey, a new user registered. It'll grab all the data from the log. It'll probably include the user's email address or something that can be used to identify and send a message to the user. And then that service will send a message off to the user welcoming them. Maybe another service is interested in the same thing. Like maybe it has to set up some database records or something and get the service ready for the new user. Who knows? So one way that this is implemented is with something called change data capture, where you have where you use a traditional database where you're just kind of, writing things to the database like, hey, new user registered, I create a user record, right? And then you'll have a process that is monitoring that database for changes. It picks up that change and it dumps that message into the log file. And then other things can kind of listen and be informed that this just happened. Well, on the project I was working on, we were thinking, well, the change data capture process is pretty heavy. We have these really tiny microservices. We would like to avoid all that weight. So we developed an abstraction where we could treat the log file itself as a database. And we did this with something called RocksDB, which is kind of like an in-memory key value store. When the process would start up, it would kind of consume the messages from the log and it would populate the in-memory data store. And then, your program could interact with this log file basically as if it was an in-memory database, very similar to what they're talking about here in SpacetimeDB. And the only reason I mention this is because whenever I was thinking about how to build this and what abstractions made sense, I decided on the reducer pattern. It's kind of a perfect pattern for implementing something like this. Whenever you're keeping the compute really close to the data, it only makes, and especially when you're working with like a key value store where you always have to write the entire record, it only makes sense that you would use this pattern because a lot of times your application only wants to make minor changes to a record, right? Like, hey, update the name. It doesn't care about what the rest of the record or object looks like. Or maybe I want to change the position of a player. I don't care what their name is or blah, blah, blah. Like there's a whole bunch of other information in that record I don't care about. I just want to change their position. So the reducer pattern is really great for this. You can say, move north. That can be a reducer function. And it reads the whole record into memory. It updates the position. Maybe it increments their Y coordinate by 1 and it writes the record back out. That is a perfect use for the reducer pattern. So the fact that they chose this pattern for SpacetimeDB makes a lot of sense. I did the same thing once upon a time. And then again, like I was saying earlier, as far as this trend towards moving compute to the data, it only makes sense. Anybody who pays attention to what's going on, especially with all the AI stuff going on and everything else, like we all know that volumes of data are just increasing exponentially. But like the size of programs really isn't, right? Like maybe a little bit, but not nearly as much as the size of the data sets. And so we can move instructions to the data really quickly now. Again, like I said, like in the beginning, like this really started on like batch jobs and like offline analytics and stuff. I mentioned I worked for a company called Joyent. Back in the day, whenever I worked for them, Joyent, for a short time, Joyent was a big deal. If you're familiar with the programming language Node.js, it's kind of a back-end JavaScript engine. Joyent hired the guy who created Node.js, and he worked at Joyent for a while. The package manager for Node.js was invented by engineers at Joyent. Joyent was competing with AWS for a little while. They were doing it with a spin-off of the Solaris operating system, which is an old, Unix operating system made by Sun Microsystems. They had released an open source version of it for Intel. At one point, Joyent took that and ran. They converted it. They spawned this new operating system they called SmartOS, and they were using that to kind of compete in the cloud space. And basically, they were competing one for one with AWS services. And one of the things they were competing with was S3, which is a service that AWS offers to store, objects. Like you can write anything into S3, you can read it back out, blah, blah, blah. Now, to my knowledge, AWS does not support compute operations within S3, but Joyent did. So they came up with an S3 compatible data storage layer. They called it Manta. And then they allowed people the ability to run arbitrary instructions on that. They had it's open source. You can come out to GitHub, Triton Data Center, Manta. You can read all about it here. There was an article posted a long time ago, back in 2014, where they talked about bringing arbitrary compute to authoritative data. And that's what I'm talking about, where you move the compute to the home of the data, the source, the source of truth. There's all kinds of terminology for this, but that's what you do. And again, this was back whenever it was focused around like batch offline. You want to run a big job that does a bunch of analytics on this huge data set. And so you write the instructions up, you send them to the cluster runs it. A couple hours later, it'll bring you back the results. Another more modern implementation of this would be Amazon EMR. They support Spark, Hive, Presto, all these various types of workloads, and these all kind of do the same thing. But again, they are all like offline, batch-centric methods. So, the idea of using this methodology for like online real-time applications, I would say this is relatively new. It's much newer than this type of work, but it's not like the SpacetimeDB is not the first time I'm hearing about this. If you've ever heard of Cloudflare, a lot of people use Cloudflare as just like an edge thing where like you'll put your website behind Cloudflare, you'll let them handle your DNS or whatever, and they'll proxy requests to your website. And the reason you do that is because Cloudflare has an enormous footprint on the internet, and they are capable of defending you from things like DDoS attacks and stuff like that. I guarantee you interact with Cloudflare almost every day because a ton of the largest websites on the internet use Cloudflare explicitly for this purpose, defending themselves against DDoS attacks and things of that nature. But you would probably never recognize it as Cloudflare. You might just see like a box pop up says, "Hey, prove you're human," and you got to like check a box and click continue or something. 9 times out of 10, that's Cloudflare doing that. But Cloudflare does a bunch of other things. One of the things they offer is their own kind of edge worker compute things. And one of those things they call Cloudflare durable objects. And if you look at, you can come out here, you can go to developers.cloudflare.com/durable-objects. That'll take you right to this page. And lo and behold, what does this say? A durable object is a special kind of Cloudflare worker, which is kind of like their JavaScript and or Rust capable workers. Just like SpacetimeDB, these are compiled to WebAssembly and they run on the edge in Cloudflare. But it's a special kind of Cloudflare worker which uniquely combines compute with storage. Sounds a lot like SpacetimeDB. Like a worker, a durable object is automatically provisioned geographically close to where it's first requested, starts up quickly when needed, blah, 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 blah. So now these are not as opinionated as what it sounds like SpacetimeDB is. It sounds like SpacetimeDB is probably going to make the process even simpler by offering stronger opinions. We got to go back and finish the video, but that's kind of at least my initial thought on this. But one thing I immediately am thinking, and I'm wondering, but as they spell out here in the durable objects documentation, like one really strong thing that Cloudflare does is like it'll spawn your durable object close to the user geographically. So if I can publish my worker, my durable object to Cloudflare, it defines its own storage, and they support a number, right? You can do relational storage, you can do key value storage, you can do whatever you want with the durable object, but they handle replicating that across the globe. So if I have a user using my application and that user is sitting in the UK, well, the durable object is kind of spawned and runs local to them somewhere in a UK data center. If I'm being accessed by a user on the west coast of America, like it's spawned in a data center over there, and it's running close to them. So that's one of the strengths of Cloudflare. I would imagine SpacetimeDB does not have that functionality, or unless you kind of set it up that way yourself, maybe with sharding or something of that nature. We'll see. We'll see if they talk about that. But so far, what I'm thinking is that SpacetimeDB is a lot like this, but it is designed to run on-premise or maybe in Clockwork Labs cluster of some sorts, like they provision it for you and kind of manage it. Whereas, obviously Cloudflare Durable Objects is specific to Cloudflare. You have to be running in their cloud to take advantage of this. But again, Cloudflare is not the only person doing this. Also, if you've ever heard of Dino Deploy, this is another service who has a lot of functionality similar to what Cloudflare offers, but it's really specific to Dino, which is an alternative to Node.js. It's another backend JavaScript runtime. But Dino Deploy is interesting and offers a lot of the Cloudflare things. And one of them is Dino KV, which is a key value store local to your Dino worker, which gives you read, write access to all the data you need. You define everything in the application, much like they're talking about with SpacetimeDB. Anyway, I mentioned these things just to say there's a lot of prior art here. I don't think any of it is exactly like SpacetimeDB, but this is kind of the way things evolve in the industry. It's very, very rare that you ever get like a truly revolutionary new technology. I don't know, aside from maybe the internet, I don't know if I've ever seen anything truly revolutionary in my time in the industry. And even the internet was a thing that was comprised of a bunch of other things that had been brewing for some time. But the way they all came together to provide the internet, that was probably the most revolutionary thing I've seen in my lifetime. Everything else is really just iteration. You're building on the previous thing, which build on the previous thing, which build on the previous thing, and eventually you wind up with something like SpacetimeDB, which is, I'm sure is going to be a nice product. Let's go back and finish the video, and we'll see if there's anything else to talk about. I hope this kind of detour was worthwhile to at least show you, that there is prior art and things have been building to this point for a while now, several years at least. I know Durable Objects was first announced back in I think 2018, 2017. I could be wrong. I'll have to look that up, but I'm sure you can go, if you just Google Durable Objects, you'll quickly find the announcement letter from Cloudflare whenever they first announced it. That was one of the, I'm only mentioning Durable Objects not because I'm trying to sell you Cloudflare service, but because it was one of the first implementations I can recall that was really providing this kind of compute local to the data in a way that was usable in real time by APIs and that type of thing. At least in the cloud. I'm actually not sure if AWS offers anything along these lines yet or not. I don't know. If you know, drop me a comment. I'd love to hear about it. All right, let's go back and finish this video.
Giving you the power to create multiplayer games you've only dreamed of. I just want to be clear. This is being simulated transactionally inside a database at 60 FPS. That is preposterous, and yet it works. Not only that, but SpacetimeDB's advanced query optimization implements incremental query evaluation to provide real-time updates for thousands of entities to thousands of simultaneously connected clients, all while minimizing network data and traffic. Single database performance is only half the battle, though. SpacetimeDB also allows you to scale your applications horizontally with intermodule communication, or IMC. With IMC coming later this year, your modules can send each other messages in real time, and SpacetimeDB will ensure they're delivered and processed exactly once.
This is something Cloudflare does as well. I don't know if Dino Deploy does this, or I'm not really aware of any other offering that does this yet, but if those durable objects that I mentioned previously, or a Cloudflare worker, they have the ability to invoke each other by like identifier, like each durable object or Cloudflare worker or whatever can have, actually it might be specific to the durable objects, but each one has an identifier, and you can invoke one from another just by having that identifier. So the same type of thing where you're using IPC to make function calls between objects.
IMC is the actor model brought to databases. So SpacetimeDB is clearly fast, but none of that matters if it isn't secure. So SpacetimeDB was built with security in mind from the ground up. SpacetimeDB is written in Rust for maximum memory safety, and all hosted modules are run inside securely sandboxed WebAssembly instances, ensuring that you, and only you, have complete control over access to your data. Conventional databases only provide coarse-grained role-based access control security models, meaning you should never allow clients to connect directly to your database. SpacetimeDB is different, though. Clients connect to the database, but they are only able to update data by calling your reducers, giving you unlimited expressiveness to write arbitrary authorization logic in your favorite language. For example, we can easily roll back a transaction by returning an error if a player is not high enough level to equip an item. This means you don't even have to learn a new security model. We're just embedding the same game server logic you've always been writing right into the database, protecting your data from malicious clients. And you can carefully and easily restrict what data can be read as well. Tables are private by default, but they can be exposed to clients with row-level security rules. These rules are evaluated per client in real time to ensure your clients only ever see rows they're authorized to see. So that's SpacetimeDB, and we think it's going to revolutionize how small teams make big games and real-time applications. We think it's going to make multiplayer applications 10 times easier to build and scale. But don't just take it from me, though. I'd like to introduce Ryan, the co-founder of Lightfox Games, who, with a team of just 8, developed Delivery Z, a mobile MMORPG, to talk about their experience developing on the platform.
Wow, okay. I didn't know other people were using this already.
Delivery Z is a fully featured MMO where you mow down zombies driving around an open world city to deliver fast food in the middle of a zombie apocalypse.
Oh,
even the
yeah,
apocalypse
fast
can't
food.
stop the gig economy. It's an MMO in the true sense of the word. You fight to expand the territory of your megacorp, blowing up other players along the way. You can see thousands of players moving around the city on the map simultaneously. We shipped Delivery Z in the middle of an apocalypse with just a handful of engineers. We started concepting the game in July and shipped it to the App Store before Halloween. 95% of the 3-month development time was spent developing the front-end client. The back end was completely plug and play. It's genuinely shocking how easy SpacetimeDB made it to create a persistent open world which can handle such a massive amount of players in one city. SpacetimeDB completely unlocked the team's creativity while enabling us to iterate incredibly quickly. It's a game changer. You can check out Delivery Z for yourself on Apple's App Store or the Google Play Store.
SpacetimeDB isn't just useful for building multiplayer games, though. It's also an extremely powerful tool for building multiplayer apps. And to talk to you about that, I'd like to welcome
A multiplayer app? Wow.
Scott, who along with his co-founder, built Pogly, a collaborative editor for stream overlays.
Streaming to platforms like Twitch, YouTube, and Kick usually is a one-person job. The streamer takes care of everything, from entertaining the viewer to the production of the stream. Pogly aims to change this, enabling streamers to offload the production of their stream to their moderation team. You and your moderators can work in a shared stream overlay editor, just like Figma. Editors of the canvas can create images, text, or customizable widgets in real time, allowing them to react to what's happening on the stream, enriching the moment for the viewer.
That's what I need.
There are dozens of pre-built widgets, from simple things like stickers to more complex things like dynamically updating death counters.
I need a moderation
With
team.
SpacetimeDB, implementing this complex multi-user application was a breeze. And with their expressive way of defining permissions, we've made it so streamers have fine-grained control over exactly who can modify their canvas and when. To top it all off, SpacetimeDB makes it easy to automatically spin up new modules hassle-free. Many top streamers, from Shroud to Mizkif, have already started using Pogly to level up their streams. So come check us out at pogly.gg.
It's so awesome to see streamers adopting Pogly so quickly. It's an amazing application. The beauty of SpacetimeDB is that as a general-purpose relational database, developers aren't constrained at all on what they can build. Even better, since we're planning to support the Postgres wire format later this year, you'll be able to incorporate SpacetimeDB into your application stack incrementally rather than from scratch.
It's really cool that, I don't know if you're familiar with Postgres. Postgres is one of the leading open source relational databases, if not the leading one. I use Postgres all the time. And this trend started, I don't know, maybe 10, 15 years ago, where more and more databases are becoming like wire compatible with Postgres. Even some of your huge cloud databases from Google and AWS and some others, as well as a lot of like the really fancy new distributed relational databases like CockroachDB, and I can't even remember the names of all of them now, but there's a lot of them, and they're all going like Postgres wire compatible. Pretty cool.
Just like you would with a regular database. Or if you need to, migrate away from SpacetimeDB by seamlessly exporting your data with a simple query. So how can you get your hands on SpacetimeDB? Well, today we're releasing SpacetimeDB Standalone 1.0, a single node production version of SpacetimeDB for free on GitHub. You can get started developing your apps and games immediately. We'd love if you give us a star. But that's not all. Today we're also releasing an even easier way to deploy into production, SpacetimeDB Main Cloud. Main Cloud is a multi-tenant managed cloud service which runs on top of a large-scale SpacetimeDB cluster. Publishing an application into production is as simple as Spacetime Publish My App. Within seconds, your application is now running seamlessly in the cloud forever. We take care of the rest. SpacetimeDB lets you focus on writing gameplay code rather than building infrastructure, networking, and serialization code before you can even get started. Persistent multiplayer games are now a fraction of the cost to develop. And with SpacetimeDB main cloud deployment, they're also a fraction of the cost to run. Running a fully featured MMORPG like Bitcraft on main cloud with thousands of concurrently connected players only costs about $5 an hour. And with our cloud energy credit system, you can see exactly what to optimize to minimize your costs. With the launch of SpacetimeDB main cloud, we also wanted to do something special for the community. The first $1 million of energy sold will be 90% off. That means you can buy $100 worth of energy for just $10, at least until we run out. You can purchase energy for your future projects at spacetimedb.com/energy.
This energy thing is funny and cool.
For enterprise clients looking for on-prem deployments or who are interested in our dedicated cloud product, please reach out at sales@spacetimedb.com. We'd love to work with you to make your dream a reality. So we have standalone for single node deployments, main cloud for the fastest and easiest way to deploy SpacetimeDB, and enterprise for those wanting dedicated clusters or on-prem deployments with enterprise customer service and support. And that's SpacetimeDB. But that barely scratches the surface of the awesome features and capabilities that it provides. There's so much more that SpacetimeDB can unlock. From database replication to DDoS protection to OpenID Connect compatibility, we've built in all the enterprise capabilities you need to run a production game. And with Bitcraft, we've dog-fooded SpacetimeDB, shaving off all the rough edges for running a production game. That ensures we run into the issues and fix them before you even see them. We cannot wait to see what you all build with this. Thank you for checking out SpacetimeDB.
Cool. Yeah, I'll definitely go give them a star. I have a lot of questions. Hopefully this this reaction was helpful, at least in kind of showing like how we may have gotten here. You know, I think the durable object stuff on Cloudflare is the closest thing I can think to SpacetimeDB, and to a lesser extent, the Dino deploy stuff I showed. If you're aware of anything similar to it, I would love to hear in the comments. Always interested in this kind of tech, and things are evolving so fast. I can't know it all, but I would say, you know, one interesting thing that SpacetimeDB has over Cloudflare durable objects would be, you know, the ability to deploy it on-prem. Obviously, you can't do that with Cloudflare, so you're kind of in their stack or you're not. And really, the Cloudflare stuff has no way of even gradual migration. You basically have to build your project from scratch to take advantage of their technology. Whereas it seems like Spacetime is planning to offer some of that in the future with like their Postgres wire protocol and stuff like that. It'd be interesting to know how that performed. What else? You know, as you know, I always say on this channel, everything's a trade-off. So I would be interested to know what SpacetimeDB is not good at. When somebody gets up and talks about how it's just the best at everything, like I immediately get skeptical. Obviously, there's going to be some trade-offs here. There's going to be some use case or situation that it's not really the best for. I would like to know what that is, because usually it's knowing where it doesn't fit that is the most informative and telling about any given technology. I do think that the opinions that they have are good ones. I think the choice of being opinionated about the state reducer pattern was a good one for the product. I think that the live queries are a really good way of supporting their target audience here, which is game developers. You know, the things like a lot of other databases all offer live queries, but I can't quite think of anything that has kind of all the features that they talk about in one package. And it does sound like a compelling package for a backend for a small indie MMO or even medium-sized one. I would like to know what the limits are. Like, I'd like to know more about how the sharding works. I didn't really get into that. That's going to be the only way you're going to be able to scale something like this. So I would love to know more about that. I wasn't sure if the free on-prem version supported sharding. They called it like single instance standalone. I think I heard him mention that's that would be an important thing to know, I guess. What else? That's yeah. I mean, that's my big questions. I'll certainly be looking into this to see what else I can uncover about its limitations, how it works, where it shines, where it doesn't, and if I succeed in learning a lot more about this product, maybe I'll do a quick follow-up video just to give even more opinions. But yeah, I mean, it sounds to me like they've got a good product on their hands, and I could see a lot of smaller developers especially be interested in this. You know, I think as you approach like Star Citizen scale or Ashes of Creation scale, I'm not sure that something like this would suffice. But again, I'm not going to really know for sure where that limit is until I learn a little bit more about it. And a lot of it will come down to cost, right? Like, obviously, they have on-prem functionalities. Even if their free tier doesn't support like on-prem sharding, their enterprise tier obviously would. But then you're looking at cost and how that stacks up to building it yourself. A lot of times, kind of like these out-of-the-box things can be really attractive, but even when you factor in like the extreme cost that somebody like CIG is paying to build Star Engine, it can still come out ahead of paying perpetually for an out-of-the-box solution like SpacetimeDB. So, and I'm not even saying that SpacetimeDB could possibly support something as grandiose and adventurous and ambitious as Star Citizen, but obviously there's a lot of games that it probably will be able to well support. I mean, their own game, Bitcraft Online looks pretty awesome. I think I'd be curious to know if like their reasoning for not focusing on combat has anything to do with technology. I'd be very curious about that because things like action combat, like the kind you see in a game like New World or Star Citizen or PAX Day, like the demands that kind of combat places on the back end and the network between players and all that stuff. That demand is pretty high, which is why you see games struggling to support it. You know, every game in alpha development right now, CIG, Star Citizen, Ashes of Creation, PAX Day, they're all kind of struggling to hit that mark. But we know it's possible. We've seen New World do it. We've seen a bunch of other games do it, but it's not easy. And I'd be very curious to know like if SpacetimeDB's performance characteristics were a reason they chose not to do that in Bitcraft or not. So anyway, hope this was useful, interesting. That's always I always enjoy looking at new technologies like this. If you're curious on like if I am thumbs upping, thumbs downing, whatever, I'm definitely thumbs upping this. It's I think it's a cool product. I can't wait to see where it goes. Who knows? Maybe I'll even try building something with it someday. What about you? Any of you curious to play around with this thing? If so, drop me a comment. I would love to hear about how you are thinking about it or thinking about using it, or if any of the games that were on the stream, like, are you interested in the Bitcraft Online or the fast food zombie apocalypse delivery game? Like, I would love to know if you're interested in any of that stuff or playing any of that stuff. Yeah, drop me a note. Love to hear about it. That's all I got for today. Hope you all have a great weekend, and we will chat again soon. Rollo out.